When it first appeared in 1974, the F-16 Fighting Falcon heralded the start of a revolution in fighter technology. It pioneered the use of fly-by-wire controls in a fighter aircraft, allowing it to be aerodynamically unstable and thus more maneuverable. It dramatically reversed the trend towards ever larger and ever more costly aircraft. And thanks to the futuristic design, the pilot commanded a view of the battle that had not been enjoyed since the earliest days of World War I. From its beginnings as a lightweight fighter optimized for tackling fighter opposition at short ranges, the F-16 grew rapidly into a true multi-role warplane. Its diminutive shape has been able to absorb the addition of ever more sophisticated equipment to keep it at the forefront of technology, although not without some penalties in terms of performance. It has also become the West's standard fighter. Huge numbers swell the US Air Force ranks, and it has consistently won significant export orders for over 25 years and still does today. Along the way, it has also notched up an enviable combat record. Only a handful of aircraft types could ever be considered as true classics in their own lifetime, but the F-16 has joined that select band while continuing to add to its reputation. As one would expect of an aircraft that had won a competition called lightweight fighter, the F-16 is relatively small. It represented a key milestone in the development of fighters as it firmly reversed the upward spiral of size and weight. In the US Air Force, it partnered the F-15 in a high-low mix, allowing the service to buy fewer of the much larger Eagle than would otherwise have been necessary. The US Navy also adopted the concept with the Tomcat and Hornet, as did the Soviet Union with the Su-27 and MiG-29. At every stage of the F-16's development, weight reduction was a key factor, leading to several innovative features. However, as the F-16 has evolved into a multi-role warplane, its weight has grown steadily. Its small size and single powerful engine provided the F-16 with sparkling performance. Despite having a fixed intake rather than a heavy and complex variable system, it can achieve Mach 2. At very low speeds, the position of the intake, fly-by-wire controls, and forward fuselage strakes provide it with excellent high angle of attack controllability, although it is not quite in the class of aircraft such as the Hornet or Typhoon. However, in the all-important transonic regime, where most air combat is fought, the F-16 truly comes into its own. Breathtaking acceleration and astonishing maneuverability allow it to fight on better or equal terms with all but the latest fighters. When it first appeared in YF-16 form, the Viper immediately demonstrated complete mastery over existing fighters. A revolution was happening in the world of air combat. Of course, the lightweight fighter prototypes were designed to be just that. The subsequent re-rolling of the aircraft added weight and drag, eroding the original performance figures. Increasing the power in the later versions has restored much of that performance, and today the F-16 remains a respected opponent in air combat across the entire speed spectrum. The F-16 carries a good weapon load for its small size. While it cannot carry the huge loads offered by aircraft like the F-15E, it does offer a wide variety of options. The only permanent weapon is the internal M61 20mm cannon, mounted in the port wing root and fed with ammunition from a drum in the central fuselage that holds 511 rounds. In the early 1990s, a few Air National Guard F-16s were wired to carry the GPU-5 pave claw gun pod on the center line. This self-contained system comprised a GAL-13 4-barreled 30mm cannon and its ammunition. It was not entirely successful and was dropped. For external stores, the F-16 has 11 hardpoints. Each wingtip forms a launch rail for air-to-air missiles, also used to carry range instrumentation pods. Each wing has 3 hardpoints, the outer of which can also mount air-to-air missiles. The central underwing hardpoint is the main weapons carrying station, while the inner wing pylons usually carry fuel tanks, but can also be used for weapons on short-range missions. The fuselage centerline pylon usually mounts a fuel tank or ECM pod, while below the chin are 2 hardpoints for sensor pods. Until the advent of the F-16 ADF and Block 30 versions, the F-16 was restricted to the carriage of short-range air-to-air missiles, which for most users meant the AIM-9 Sidewinder. For the US Air Force, the AIM-9L and M were the main versions, but some export users employed the older AIM-9P. The highly maneuverable AIM-9X is being cleared for carriage by the F-16, which when used in conjunction with a helmet-mounted sight will allow the Viper to make high off-bore sight shots. Export F-16s have also adopted alternatives to the Sidewinder. For instance, Pakistan's aircraft have used the Matra Magic II, while the aircraft of Israel employ the Israeli Python family, including the latest Python 4 and 5. Venezuela also bought Python 4s for its Vipers, and the missile is used by Singapore. Medium-range capability came belatedly to the F-16 when the ADF version was produced with the ability to fire the AIM-7 Sparrow, carrying a pair of the missiles under the center wing pylons. AIM-120 AMRAAM capability was introduced by the F-16C and D Block 30, and also retrofitted to many earlier aircraft through midlife update programs. It has become the principal air-to-air weapon since, at least for American and NATO aircraft. AMRAAMs are usually carried on the wingtip rails, with AIM-9s on the outer pylons. Israeli aircraft also use the Rafale Derby medium-range active radar missile. The F-16 was also used as a test platform for the British Aerospace ASRAAM seen here. In the attack role, the good nav attack system of the Fighting Falcon allows it to make free-fall attacks with considerable accuracy. Dumb weapons still form an important part of the inventory, centered on the Mark 80 series. A single Mark 84 can be carried on each of the center and inner wing pylons, or up to 12 Mark 82s on triple racks. Other freefall stores include a range of tactical munitions dispensers, including those fitted with the wind correction kit that improves accuracy. US Air Force F-16s are also wired for the carriage of nuclear weapons, for which the tactical B-61 is the principal option. Many F-16s are equipped with laser designation pods, so the Paveway family of laser-guided bombs is a popular option for precision attacks. The GBU-10 and GBU-12 Paveway 2 bombs are the most common, but the more expensive Paveway 3 family can also be used. Israel has also developed a similar family of laser and infrared guided bombs. A weapon now seen very regularly is the GPS-guided JDAM, available in 500-pound, 1,000-pound and 2,000-pound warheads. Cheaper than the Paveway, the JDAM is not quite as accurate, but is nevertheless very useful for achieving near-metric precision. The JSOW Standoff Glide Bomb is another GPS-guided option. The AGM-154A is the main version, its warhead consisting of multiple bomblets that are dispensed over area targets. For many years, the F-16 has employed the AGM-65 for precision attacks, carrying the missile up to 3 at a time on underwing pylons. The Maverick employs electro-optical guidance using either daylight or infrared and is used against small precision targets such as armor. Larger weapons available to the F-16 are the electro-optically guided AGM-142 HAVNAP and the AGM-158 Joint Air-to-Surface Standoff Missile. Since Block 30, the F-16 has had a limited anti-radar capability through the AGM-45 Shrike, but this has been superseded in later aircraft by the much better AGM-88 HARM. Up to 4 can be carried on the wing pylons, although 2 is a more usual number. The final class of weapons available to the F-16 is radar-guided anti-ship missiles. Some export aircraft are cleared to fire the AGM-84 Harpoon. For Norway, the Viper has also been cleared to fire the smaller Penguin, designed and built locally by Kongsberg. For its multi-role mission, the F-16 was provided with a multi-mode radar with a variety of air-to-air and air-to-ground functions. In the F-16A and B, the radar was the Westinghouse APG-66. In the C and D models, this was replaced by the APG-68 with greater range, improved resolution, and other improvements. The APG-68 has been continuously updated during the life of the Fighting Falcon, and the Block 50 aircraft now has the APG-68 V5. The signal processor of this radar runs at twice the speed of its predecessor in the Block 40 machines. Similar features are found in the APG-66 V2 radar, now used by upgraded F-16As. The aircraft is also well defended. US Air Force F-16Cs and Ds being equipped with the ALR-56M radar warning receiver set. Characterized by the beer can antennas on the leading edge of the wing, the system detects a wide range of ground and air threats, analyzes and prioritizes them, and automatically controls the ALE-47 dispenser system. Jamming pods such as the ALQ-131 can be carried, and there is capacity for an internal jamming system. A more sophisticated radar location system is carried by Block 50 and 52 aircraft operating in the Wild Weasel role. Designated ASQ-213, the HARM targeting system is carried in a pod under the starboard side of the intake. It allows the F-16 to fire HARM missiles in range-known mode, allowing for greater flexibility when attacking radars and increasing the probability of a kill. Podded systems have turned the later Fighting Falcon versions from daytime free-fall bombers into nighttime platforms that can deliver laser-guided weapons with great precision. Introduced by the Block 40 and 42, the first such system to be fielded was the Lantern. Also used by the F-15E, Lantern comprises 2 pods carried under the intake. On the port side is the AAQ-13 navigation pod, containing a terrain-following radar and a wide-angle fixed infrared sensor. On the starboard side is the AAQ-14 targeting pod. This has a fully articulated sensor ball in the nose containing an infrared system for target acquisition and a laser designator. The Lantern system is still a valuable tool, but the changing nature of aerial warfare and the march of technology have seen it superseded by a new generation of targeting pod. The Rafale Lightning Pod from Israel is a popular targeting device used by a number of nations, including the US Air Force, which bought it for its older F-16s in the reservist units. Active duty US Air Force units are now using the Lockheed Martin Sniper XR pod. This is carried from the starboard intake hardpoint and contains a much more capable infrared sensor than the Lantern. For the pilot converting to the Viper from an earlier aircraft like the Starfighter or Phantom, the F-16 cockpit must have initially seemed a most alien environment. Firstly, the pilot sits much higher up than in previous aircraft. Then there is the seat reclined by 30 degrees. This was partly a result of being the only way the ACES 200 ejection seat could be fitted into the tiny forward fuselage, but gave the added benefit of increasing the pilot's resistance to G-forces. Then there is the side stick controller, the F-16 being the first aircraft to adopt this feature in place of a conventional control column. The side stick caused some controversy at first, but pilots have adapted to it readily, and it has never been a cause for concern. And finally, there is the view. Sitting high up underneath a frameless bubble of glass, the pilot has a view of the outside world unrivaled by any other fighter. Without moving his or her head, the F-16 pilot can see 15 degrees down over the nose, 40 degrees down to each side, and over the entire upper hemisphere. A full glass cockpit was introduced by the F-16C, represented here by a Block 50 aircraft. The cockpit is dominated by a large head-up display for showing crucial flight and combat information. The HUD in the Block 40 and 42 is larger and can also show FLIR imagery. Below the HUD is an upfront control panel for data entry. Below that is the central console housing the main flight instruments, comprising airspeed indicator and altimeter, below which are angle of attack indicator, attitude indicator, and a half dial for vertical velocity. Below them are autopilot controls, vertical situation indicator, and fuel quantity select switches. To the left of the upfront controller is the radar threat warning display, below which is a multifunction display with arming switches outboard. A sloping side panel below that mounts aircraft system controls for the undercarriage, brakes, flaps, air brake, and emergency stores jettison. The left side console mounts the main radio switches and the throttle. On the other side of the cockpit, the right console has further systems panels, including one for lighting, and mounts the side stick controller. Behind the controller is an elbow rest. The right-hand sloping panel has a warning panel and standby compass. Above this are the main engine dials, with the right-hand multifunction display alongside. Above this is a backup attitude indicator. And alongside the upfront controller is a small panel showing digital readouts of navigation and communication information. In the Block 60 aircraft for the United Arab Emirates, the F-16 cockpit has undergone yet another transformation, with three large rectangular color screens dominating the cockpit. All F-16As and Bs are powered by the Pratt & Whitney F-100 engine, similar to that fitted to the F-15 Eagle. This power plant was powerful, but had to be managed carefully in certain areas of the envelope. In 1986, the F-16 Block 30 appeared with the General Electric F-110 engine, offering greater power and better stability. From then on, engines from both manufacturers were purchased in parallel. The F-110 was initially available in the Dash 100 version. This was later superseded by the Dash 129, which had considerably more power to offset the aircraft's growth in weight. The General Electric engine can be distinguished from its rival by having a curved nozzle section. Pratt & Whitney refined its engine, first producing the Dash 220 with digital systems and more stability, and then the Dash 229 with power to match General Electric's Dash 129. The latest engine for the F-16 is the yet more powerful F-110-132 installed in the Block 60. The chin intake with its characteristic smile is ideally placed for maneuvering. It has no moving parts and is separated from the fuselage by a prominent splitter plate. The intakes of F-110 powered aircraft are about 10% larger than those with Pratt & Whitney engines to provide a larger mass flow of air. Fuel is held in a bag-type tank behind the cockpit, in a central integral tank, and in the interspar area of the wings. For all but the shortest missions, the F-16 carries drop tanks. This was accepted at the design stage as a more efficient means of providing the necessary range without having to make the fuselage any larger than was ideal. A boom receptacle is fitted for in-flight refueling, although there is an option to fit a probe for receiving fuel from drogue-equipped tankers. It has not been adopted. Control of the aircraft is handled by a 4-channel digital fly-by-wire system. As well as ensuring stability for the otherwise unstable aircraft, it protects the pilot from straying outside the envelope, in turn allowing carefree handling. Control surfaces comprise a single-piece rudder and all moving tailerons that work together for pitch control and differentially for roll control. Roll control is also handled by large flaperons on the trailing edge of the wing. As their name suggests, they also droop to act as flaps. The nose wheel retracts rearwards and the main gear retracts forwards, all wheels being housed in bays underneath the intake. Either side of the engine nozzle are small air brakes that open up to 60 degrees. On the ground, US Air Force F-16s rely on their anti-skid braking system with an airfield arrestor hook under the rear fuselage for emergencies. Some export operators also have a brake chute housed in an extension at the base of the fin. Over 4,000 F-16s have been built by Fort Worth and 4 licensed production sites in Belgium, the Netherlands, Turkey and South Korea. Deliveries of F-16s got underway to the US Air Force on the 6th of January 1979, the 388th Tactical Fighter Wing at Hill Air Force Base in Utah being the first recipient. From then on, the Fort Worth facility poured out Vipers by the hundred to allow the F-16 to become the service's staple tactical asset. In US service, the F-16 largely replaced the F-4 Phantom. As well as home-based units, the F-16 was stationed overseas in West Germany, Japan, South Korea, Spain and Italy, and several of these units remain today. The reservist units in the Air National Guard and Air Force Reserve also converted wholesale to the F-16, initially with F-16A and Bs cascaded down as the front line received newer F-16Cs and Ds, and then with new aircraft of their own. The F-16 was also issued to the Thunderbirds team based at Nellis to replace the T-38 Talon. The team flies a noisy, six-ship display of immaculate formation flying and aerobatics. Today, the F-16A and B is largely gone from US service, a few remaining with test and trials units. The active duty fleet is equipped with Block 40 and 50 machines, as are a number of reservist units. The US Navy has also operated a few F-16s, using them to imitate foreign aircraft for advanced air combat training. From the start of the F-16 story, it was clear that exports would play a large part. This was emphasized as early as June 1975, when 4 European partners signed to buy the aircraft in what was then known as the sale of the century. Belgium, Denmark, the Netherlands and Norway formed a partnership not only to buy the aircraft as a joint replacement for their starfighter fleets, but also to produce it under license. While the main factory at Fort Worth geared up to build the F-16, so production lines were established at Schiphol in the Netherlands and Gosselies in Belgium. The 4 nations began receiving their aircraft in 1979 and 1980, at a similar time to initial US deliveries. Much later, they would band together again to see through a major midlife update program for their fleets. Belgium bought a total of 160 aircraft. Denmark took 70 plus 7 ex-US machines. The Netherlands acquired a total of 213, while Norway's purchases totaled 74. Israel was another important early customer, acquiring its first aircraft in July 1980. In June 1981, they successfully attacked the Osirak nuclear reactor in Iraq. A year later, Israeli F-16 scored the type's first major combat success, shooting down 44 Syrian aircraft for no loss during hectic battles over the Bekaa Valley. More than 360 F-16s were delivered to Israel, including many in F-16D big spine configuration. Following the 1979 thawing of relations with Washington, Egypt acquired the F-16. The first batch of 42 aircraft were Block 15 F-16As and Bs, but the following aircraft were F-16Cs and Ds, including some built in Turkey. Total Egyptian procurement has reached 220. Elsewhere in the Middle East, the F-16 has been bought by Bahrain, which acquired 22 F-16Cs and Ds. Oman with 12 Block 50 aircraft. And Jordan, which picked up 36 surplus F-16As and Bs, including some in ADF configuration. The United Arab Emirates bought 80 of the latest F-16E and F Block 60 version. Pakistan acquired 40 F-16As and Bs and has recently ordered 24 Block 50 F-16Cs and Ds. Europe has provided a rich marketplace for the F-16, in addition to the original 4 customers. Greece bought 180 F-16Cs and Ds from Block 30, 50 and 52 production. Across the Aegean, Turkey acquired 240 Block 30, 40 and 50 aircraft, most built locally by TAI. Italy has leased 34 F-16As and Bs, mostly in ADF configuration, to provide an interim air defense capability until sufficient Typhoons have been delivered. Portugal acquired 45 surplus F-16As and Bs, of which 20 were updated as part of the European MLU program. The latest European customer is Poland, which received the first of 48 Block 52 aircraft in 2006. In South America, Venezuela was the first customer, buying 24 F-16As and Bs. More recently, Chile bought 10 new-build F-16Cs and Ds, supplemented by 18 second-hand aircraft from the Netherlands. The Pacific Rim has been another lucrative market for the F-16. South Korea has 180 Block 32 and 52 machines, most built locally by Korean Aerospace Industries. Thailand has taken delivery of 61 F-16As and Bs, including 7 donated by Singapore in return for training facilities. Having given away its earlier aircraft, Singapore now operates a fleet of 62 Block 52 aircraft, 40 of which are big spine two-seaters. To the south, Indonesia also flies the F-16. a dozen F-16As and Bs having been delivered. The final Far East F-16 operator is Taiwan, which flies 160 Block 20 F-16As and Bs. This version is similar to the MLU aircraft operated in Europe. Mention must also be made of Japan, which flies the related Mitsubishi F-2. Tasked in the fighter support role with anti-shipping a speciality, the F-2s fly with 3 Hikotai at Misawa and 21 Hikotai at Matsushima. A total of 98 is to be built. Having served with so many users for such a long period, it is no wonder that the F-16 has compiled a long and distinguished combat record. For US aircraft, the first main action came in the 1991 Gulf War, when F-16s flew numerous battlefield interdiction and close air support missions. With 249 aircraft deployed, it was the most numerous fighter deployed by the coalition. In December 1992, in the aftermath of Desert Storm, an F-16 scored the first kill for the AMRAAM missile, downing an Iraqi MiG-25. The F-16 was also the mainstay of the effort over the Balkans in the 1990s, US Vipers being joined by those from other NATO allies. In February 1994, a pair of US F-16s shot down 4 Serbian Galebs during an air policing sortie. Later, during the 1999 war over Kosovo, a Dutch F-16 shot down a MiG-29 with an AMRAAM. Another fulcrum fell to a US F-16 later in the conflict. Most recently, US F-16s have been at war over Afghanistan and Iraq. In both theaters, F-16s have been used in the defense suppression role. However, close air support has been the most important mission. The F-16s employing laser and GPS-guided bombs to take out pinpoint targets to aid friendly ground forces. Today, the F-16 is the bread and butter aircraft of the US Air Force and its many export customers. While more expensive and more sophisticated types often play specialized roles, it is the F-16 that fills the gaps and makes up the numbers. Consequently, the Fighting Falcon, or Viper as it is colloquially known, can undertake a wide variety of mission types, from close air support to air superiority. It has shot down aircraft over the Balkans, taken out radars in Iraq, and supported troops in Afghanistan. While the mainstream US Air Force fleet shares capabilities in terms of air defense and general-purpose bombing, the advent of the Block 40 and 50 in the late 1980s and early 1990s saw the frontline force increasingly divided into 2 distinct mini-fleets. The Block 40 and 42 Night Falcons, collectively termed F-16CG on US Air Force tasking orders, had precision attack by night as their speciality, while the Block 50 and 52 machines, known as F-16CJs, have developed defense suppression as their forte. Equipped with the Lantern pod system, the F-16CG had all the tools necessary for its role. A typical loadout would have been sidewinders for self-defense, fuel tanks on the inner wing pylon, and GBU-10 laser-guided bombs on the center pylons. The Lantern system was carried under the intakes, and a jamming pod like this ALQ-131 on the center line. In a high-threat environment, the F-16CGs would ingress at low level, using the Lantern navigation pod's terrain-following radar, backed up by visual imagery from the pod's forward-looking infrared sensor being shown on the HUD. The lantern targeting pod provided a narrow field of view FLIR for target acquisition and a laser designator for the accurate delivery of the bombs. Due to changes in the nature of the threat and advances in sensor technology, the accent has now moved to medium-level operations, F-16s now often using the latest sniper pod in place of lantern. Nevertheless, the Viper remains a very accurate laser bomber. Whereas the specialist talents of the F-16 CG are not as important today as they were in the early 1990s, the F-16 CJ has emerged as the US Air Force's main weapon in the war against enemy radars. When the Air Force retired the F-4G Wild Weasel in the early 1990s, there was no dedicated platform to continue the role, despite numerous plans. Instead, the F-16 CJ began to carry the ASQ-213 HARM targeting system. While this is not as capable as the F-4G, it nevertheless offers a significant percentage of the capability at a vastly reduced cost. A typical defense suppression loadout comprises self-defense AMRAAMs and sidewinders, fuel tanks and ECM pod if required, and an AGM-88 HARM under each center wing pylon. Like its Navy Hornet counterpart, the F-16 CJ can operate in a number of defense suppression profiles. It can fly ahead of the main strike package to open up gaps in the defenses. It can fly escort missions, riding shotgun on the main attack force to protect them. And it can loiter in the battle area to rapidly target any radars that might present themselves. In the latter half of the 1960s, while US fighters were having a hard time countering North Vietnam's nimble MiGs, the US Air Force was in the middle of procuring a high-performance heavyweight fighter. This eventually materialized as the F-15 Eagle, powerful and capable sure enough, but also large and costly. By the end of the decade, a small group of individuals, who would later be termed the Fighter Mafia, were lobbying for a much smaller fighter. Their studies showed that by returning to the fighter's traditional values of agility and fast acceleration, a small fighter could outmaneuver and outfight any opposition. Their lobbying bore fruit in January 1972, when the US Air Force instigated its Lightweight Fighter, or LWF, program. 5 companies responded to the LWF request for proposals. Among them was General Dynamics, whose Harry Hilliker had been a key proponent of the lightweight fighter. It was no surprise that his team's Model 401 design was awarded a development contract in April 1972. Northrop also received a contract for its P600 design, a product of another fighter maverick, Lee Begin. The Model 401 was a remarkable-looking aircraft. Hilliker summed up the design approach as wrapping the smallest aircraft possible around the largest engine we could find. The wing was thin for low drag and straight for maneuverability. It was fitted with automatic leading-edge flaps that altered the camber throughout the speed regime. In the pursuit of lightness, Hilliker's team blended the wings into the fuselage, making the wing roots thicker and stronger, but also providing internal volume. A single fin was found to be the most efficient configuration. Careful attention was paid to the forward fuselage, where detachable sharp-edged side bodies produced powerful vortices over the wings. The intake was slung under the chin, where it could gulp the most air when maneuvering. The pilot was given the best view possible by being seated half outside the aircraft, covered by a huge bubble of glass. A key factor was the use of fly-by-wire technology. By making the Model 401 unstable, the aircraft would be more maneuverable and the control surfaces could be made smaller. Although fly-by-wire technology was still in its infancy, the General Dynamics team decided that its benefits far outweighed the problems that might be encountered. Nevertheless, there were some insurance features. The intake and four-body strakes were built as separate structures so that they could easily be replaced if there were troubles. The structure even catered for the wing to be moved back if the relaxed stability could not be achieved safely. Two prototypes were ordered for the LWF evaluation, designated YF-16. Phil Oestreicher made the first flight on the 20th of January 1974 when he encountered problems during a high-speed taxi run and decided that the aircraft was safer in the air. An official first flight followed on the 2nd of February. During the extensive LWF evaluation, the YF-16s performed excellently, fighting and winning in mock combat against a wide range of opponents. Maneuverability at transonic speeds was particularly good, although the rival Northrop design, the YF-17, was better at low speeds. There was an incident, however, including a belly landing when the undercarriage got jammed in the up position. During the evaluation period, the LWF program became the Air Combat Fighter. ACF looked to provide the low end of a high-low mix to partner the F-15 and to provide a limited air-to-ground capability. At least 650 aircraft would be required. On the 13th of January 1975, the US Air Force selected the YF-16 as the ACF winner. It was cheaper than the YF-17, and its single F-100 engine provided commonality with the similarly powered F-15 fleet. Early production F-16As introduced a number of important changes. The wing was enlarged slightly, the fuselage was slightly shorter, and a much larger radome was installed to house the antenna for a multi-mode radar. There was also a two-seat aircraft known as the F-16B. It traded some internal fuel capacity for the second seat, but retained the full combat capability of the single-seater. The first major change came with Block 15 production, which featured larger tailplanes to counter the effects of carrying sensor pods from the newly installed hardpoints under the intakes. A large number of US Air Force Block 15 aircraft were later modified to the Air Defense Fighter variant. The ADF was given Sparrow missile capability and fitted with airborne searchlights. They were issued to Air National Guard units to perform homeland air defense missions. Other early variants were the F-16-79, which flew with a J-79 engine from the Phantom as a potential reduced-spec export aircraft, and the F-16-101, which tested a General Electric F-101 engine. F-16AB production continued alongside that of the later F-16CD for some time, incorporating many of the improvements developed for the later aircraft. Many aircraft were subsequently upgraded in both structural and equipment terms under various midlife update programs. There were several important research aircraft, such as the YF-16 Control Configured Vehicle. The Advanced Fighter Technology Initiative testbed had large side force generators fitted to evaluate many sophisticated fighter and attack technologies. The Vista testbed had a variable stability system and was later modified to become the multi-axis thrust vectoring platform. The most radical departure from the design to take to the air was the F-16XL, which mated a lengthened F-16 fuselage to a very advanced cranked arrow wing. Returning to the mainstream production, General Dynamics introduced the F-16C and D in 1984 with the Block 25 machine. This had a new radar and a new glass cockpit with wide-angle head-up display. Externally, it could easily be recognized by the lengthened dorsal fin. Nagging problems with early F-100 engines had prompted the US Air Force to ask General Electric to develop an alternative engine, the F-110. This was based on the F-101 tested previously. It was heavier than the F-100 but was more powerful. Pratt & Whitney, meanwhile, continued to improve their engine. General Dynamics reworked the F-16 with a common engine bay able to take either power plant, and both were bought by the US Air Force. When fitted with the F-110, the aircraft were Block 30s. The Block 32 had Pratt & Whitney power. GE-powered aircraft had a bigger inlet to satisfy increased mass flow requirements. At the same time, the ability to carry the new AMRAAM missile was introduced, as well as the AGM-45 Shrike anti-radar missile. Among the Block 30 aircraft were several stripped-down F-16Ns and two-seat TF-16Ns, which were bought by the US Navy for adversary fighter training. The Block 30 and 32 had featured a number of new systems that offered considerable potential, but which could not yet be fully exploited. General Dynamics embarked on a two-pronged approach to address this, the first of which was the F-16CD Block 40 and 42. Alternatively known as the F-16CG or Night Falcon, this variant introduced the Lantern system with chin-mounted pods. A new head-up display allowed infrared imagery from the pods to be displayed, giving the pilot a window in the night, while the pod's terrain-following radar greatly enhanced the aircraft's ability to undertake low-level attacks at night or in bad weather. The accent was placed on precision attack, for which ordnance options were increased by a beefed-up undercarriage to handle greater weights. It was also the first combat aircraft to have a fully integrated GPS system. All this extra kit had raised the weight of the F-16 considerably and consequently eroded performance. In the second prong of its F-16 development, General Dynamics sought to restore some of the performance loss for the baseline fighter. Under the Increased Performance Engine program, both General Electric and Pratt & Whitney had developed much more powerful engines which were fitted to the F-16 to create the Block 50 and Block 52 respectively. The Block 50 and 52 had Lantern capability, although it was not used. Instead, US Air Force aircraft were given the defense suppression specialty. The aircraft featured the ability to launch the AGM-88 HARM missile, which was enhanced by the adoption of the HARM targeting system pod carried under the starboard intake. A big spine modification was developed for the F-16D two-seater, pioneered by Israel. Japan, meanwhile, used the F-16 Block 40 as the basis for a new multi-role fighter, initially known as FSX and later as the F-2. The design began life as the Agile Falcon project, with a much larger wing and tailplane and a lengthened fuselage. Mitsubishi led the F-2 project, working closely with General Dynamics. Japan wanted a larger aircraft with greater range and the ability to carry up to 4 ASM-1 or 2 anti-ship missiles. A high Japanese content was specified, including new cockpit systems and a phased array radar built by Mitsubishi Electric. Powered by the General Electric F-110 engine, the first F-2A single-seater took to the air for the first time on the 7th of July 1995. The first two-seat F-2B followed on the 18th of April 1996. By this time, the F-16 was a Lockheed Martin product, as Lockheed bought the Fort Worth factory from General Dynamics in 1993 and 2 years later merged with Martin Marietta. In this time frame, the F-16 ES was evaluated. This version had sensor balls in the nose to replace the podded systems and had 2 large conformal fuel tanks added either side of the fuselage spine. This sophisticated long-range version was aimed at an Israeli requirement eventually fulfilled by the F-15I. Nevertheless, work on the F-16 ES was of inestimable value when Lockheed Martin developed the ultimate fighting falcon, the Block 60.
次号はユーロファイター。ドイツ、イタリア、スペイン、イギリスが共同で開発したユーロファイターはヨーロッパの誇りをかけた最新の多用途戦闘機です。驚異の最新技術を駆使したこの戦闘機は今後数十年にわたってヨーロッパ防衛の中核となる存在です。次号もぜひお求めください。